All right, here's our first example. So I'm going to do only the hard ones. There's some in the book where they give you the picture, and if it's the picture, you can immediately look, you can immediately see what you have. There's going to be some where they're not going to give you a picture, and I'm just going to do them all where you don't have a picture, so that way we get in the practice of drawing a picture. So first thing I do is I'm going to draw a triangle, and in all honesty, it doesn't really matter if it's drawn perfectly to scale. Both of these are acute angles. I'm going to put angle A here. This is 63 degrees. Angle B is 51 degrees, so that makes this angle C. So side A is opposite angle A. This is 13, which means this is side B, and this is side C, okay? So they may ask you for a particular angle, a particular side, or if they tell you to solve a triangle, that means you have to find everything that's missing, okay? Well, in this situation, I'm given angle, angle, side, okay? Angle, angle, side. Anytime you have two angles, you're always going to be able to use the law of sines. That's an easy way to remember it, okay? I don't even have to look at my sheet. Finding your third angle, easy. Measure of angle C equals 180 minus 51 minus 63. And I'm going to use a calculator today so I don't screw any of this up. So 180 minus 51 minus 63. And so this is 66 degrees, okay? Now, very important, throughout this chapter, we've been flipping back and forth between degrees and radians. We're in degrees. So eventually when we get to using sines and cosines, you have to make sure that your calculator is in degrees. That's one of the hardest parts about this test is you quickly forget, oh, I got to change the mode of my calculator. Am I in degrees? Am I in radians? What are they asking for? So under mode, I'm already in degrees, so I'm good. I don't have to change it. And anytime any of these problems with law of sines and law of cosines, none of it will be in radians. It's all going to be in degrees, okay? So law of sines, you can have any two of the three, okay? So I can have two angles and then I can have one side. I can have one angle and two sides, and it can be any combination in order to use law of sines. And it can be these two or these two or these two, okay? Let me get my pencil out of there. So it doesn't matter what it is. And because it's going to be a proportion, it doesn't matter if you put the signs on top or the signs on bottom. They just have to be in the same spot, okay? I prefer to always use my signs on top. I don't know why, personal preference. Maybe it's the way I learned it. I'm going to keep my signs on top, okay? So I'm going to use the two angles that I was given, and I'm going to solve for side B first. So I have the sine of 63, which is the sine of A, over side A equals the sine of 51 over, and I've got to look for angle B, okay? Or excuse me, side B. So you can cross multiply. I do not expect you to write this out, but when I cross multiply, I have B times the sine of 63 equals 13 times the sine of 51. And then I'm going to divide by the sine of 63. I can't tell you enough to not approximate anything until you get your final answer. So I'm not going to plug any of this in my calculator till I get B by itself, and then I'm going to plug this whole thing in my calculator all at once. So I'm going to go on the calculator, and I'm going to say, all right, 13 sine of 51 divided by sine of 63. And so to the nearest tenth, side B is 11.3. Now, if this were a right triangle, I could go through and I could do the Pythagorean theorem. It's not. So I have to use, again, law of sines. I'm going to stick with what I know for certain. These are not decimal approximations. These were given to me. So I have the sine of 63 over 13. And now to find side C, I'm going to do the sine of 66. And that's exact. That's not a decimal approximation, over C. So same thing, cross multiply and divide. So C is going to be equal to 13 times the sine of 66 over the sine of 63. So again, I will plug that in my calculator. So 13 sine of 66 divided by sine of 63. And then this is approximately 13.3 to the nearest tenth. And so if I go back, when I get done with these, I always go back and I look at, does this seem reasonable? Okay, so my angle C was 66 degrees. Side B is about 11.3 and side C is 13.3. Largest angle, we learned this in geometry, but the largest angle should be opposite the longest side, okay? And the smallest angle should be opposite the shortest side. And then those should be in between. And these are all, it's not quite an equilateral triangle, but it's close. And notice how close these all are as well. And so that seems very reasonable. And this would be an example of when we're given an angle, angle, side. Possibility.